are now at 12:30. So we can go ahead and get started. Okay, gotta make sure that I have. Okay, there's chalk over there. Cool. All right. So, welcome everybody. Welcome back to another wonderful iteration of CSE 8A, Intro to Programming in Python. Today we're going to be going over images and tuples. Okay, images is basically what it sounds like, a picture, right? And how we can work with pictures in the computer. And also tuples. Tuples is a new data type. So what other data types have we heard so far in the class?
Lists.
Lists.
Strings.
Strings. Ints.
Floats.
Floats. Yeah. Thank you, Angel. Yeah. And so tuples will be a new one. Tuples is going to be a new data type they're going to be working with. Right. So, before we get into the actual material, some announcements. Midterm exam grades have been released. You all should have gotten access to your grades by now. And your final exam can help improve your midterm grade. So whatever grade you got right now, right, remember that if your final exam is higher than your midterm exam, we will replace your midterm exam grade with the average between your midterm and your final. All right? So you still have an opportunity to bring up your score if you'd like. We also have curved the grade. So it used to be out of 48 points, but the highest grade was 46 points. So now everything's graded out of 46 points. Okay? So you may have gotten a little grade boost on that. Let's hope. PA4 is due today. Reminder that you please go to any and all office hours that you can. There's office hours, tutor hours. We also sent out, this is the last point here, the one-on-one tutoring. You know, if you'd feel uncomfortable, going to the regular tutor hours that we have, we're also going to offer one-on-one tutoring because we have a wonderful staff and we have enough staff members to help you all out one-on-one. Okay, so if you have any questions whatsoever, please also sign up for one-on-one tutoring. All right. So yeah, PA4, that's due today. Make sure that you can submit that by today. If you have not used any slip days, you can still, again, use 2 of your slip days, 2 of your 5 allotted slip days. And then PA5 has now been released. Y'all should already be able to see PA5 released over on EdSTEM. We're going to be going over a lot of material today that is going to help you with PA5. Okay? And make sure to go to the discussions. They're really helpful for the PAs, right? Discussions are really helpful for PAs and really helpful for exam stuff, all right? You may or may not have seen, but in the discussions leading up to the exam, we covered a bunch of questions that were very similar to that of the exam. So, again, it's optional to go, but I highly recommend it, okay? Highly recommend you go to discussions. Any other questions so far? On PA stuff, discussion stuff, midterm things? Yes, no, yes, no. Y'all could see your grades, right? For the midterm and for the PAs? Great. Cool. And there's the link if you want to sign up for one-on-one tutoring. Okay. All right. So, last week we covered nested for loops and to-do lists. Can someone remind me what a nested for loop is? Yeah?
It's a list. No, it's a for loop inside of another for loop.
It's a for loop inside of another for loop. Right, yeah. Nested for loops. So both are for loops. You have a big old for loop, and inside that big old for loop, you have another for loop inside it. So anytime you hit that inner for loop, you have to do all the iterations of that inner for loop, and you work your way around, back outside the bigger for loop, right? And then you loop all the way again, and you hit that second for loop, and you do it all over again. Okay. 2D lists. What are 2D lists again?
A list inside of another list.
A list inside of another list, right? You could also think of it a list of lists. Right? Just a bunch of lists within another list. And we actually used our nested for loops to go through a 2D list. Right? First, we would go through each one of the lists that we have inside the big list. Then, within your new list that you have inside, we'd iterate through each one of those little items. Right? They could be numbers, strings, anything really. But we used our nested for loops to go through that. And we also have done some variable updates, right? While you're in your nested for loop, you could be updating variables as you want. You could update the actual 2D list itself. You could update some counters, right? Any sort of variable that you have, right? So, as a quick exercise, if y'all have a laptop out, if you could please take it out and go over to lecture 13 on EdSTEM for one of the lessons. And try to write this out. If you don't have a computer with you today, that's totally fine. You can do it on like pen and paper if you have any. So just try to write it out, right? You could code it out just on your pen and paper or code it out on the system itself on EdSTEM. But I'd like for you all to get this piece of data, right? 10, 20, 30, 40, 50, 60, 70, 80, 90. This is a 2D list, remember, a list of lists. And I'd like for you to write out a nested for loop that prints out 10, 20, 30, 40, 50, 60, 70, 80, 90, like this in this order. 10, 20, 30, 40, all the way to 90. Okay? I'm gonna give you all like around 5 minutes to work on this, okay? If you have any questions while you're writing it out, let me know, and I'll try to help you all out, okay? How are we doing on progress? Are we doing on progress? Okay. Nested for loop to print out all these values. You got the answer? How much you typed? You got the answer?
I think so.
Okay. So, how can we go through this data using a nested for loop to print out all of our necessary, to print out all the things that we're looking for? So we're looking for a program that can get this 2D list, this list of lists, and we just want to print out these elements in order. Okay. So first things first, for a nested for loop, what should we use? A for loop. Great. For. Then what are we going to put right next to the for? What can we put here? Maybe row. All right. Row. We can call it anything we want, right? We can call this X, we can call it Y, we can call it row, we can call it Caesar, Angel, Ella, or Tyler, right? We can call it whatever we want. So we're going to call it row for now. For row, in, what do we want to iterate through?
Data.
Data. Awesome. Data. Right? Don't forget the colon at the end, and then enter in. Right? So now I have for row and data. Let's just print out row just to see where we're at. What are we actually looking at? So I'm going to put print row is equal to, I'll put sir row. Let's just see what it looks like. Okay. So each time we're going through the for loop, row is first going to be 10, 20, and 30. Then it's going to be 40, 50, 60. Then it's going to be 70, 80, 90. Okay. So now we have this variable called row. Now, with a nested for loop, what should we be doing? We have one for loop here. We have our row, and row is a list. What should we do next?
Another for loop.
Another for loop. For. What do we want to call this one?
Num.
Num. Great number, or great name for numbers. For num in
Row.
row. Okay. For num in row. Why are we putting row here, Caesar?
Because you want to go through each list.
You want to go through each list, right? So we're doing that like this. We go through each list. That's with a row. Is that, am I understanding correctly?
Or you want to go inside the list data, and then inside of each of those individual lists, you want to go through each number.
Right. So data is a list of a bunch of lists, right? And then you're saying we want to go through each one of the numbers within each one of these lists, right? So we're saying for num in row. Row at this spot could be one of these three things, right? Either this list, 10, 20, 30, this list, 40, 50, 60, or this list, 70, 80, 90. Great. So for num in row, what we can do now is, let's just print out num is equal to, and then stir num. Let's just see what happens, right? Let's just see what happens. Again, we don't know if this is the right answer yet. We don't know what's going on yet, but we just want to see where are we, right? What are we doing? Where are we? Let's run that. Ooh. Okay. So now we see, we print out that we're in this row, 10, 20, 30. Then we see that num goes through each one of these elements within the list, right, of 10, 20, 30. Num is first 10, then num is 20, then num is 30. We finish with that inner for loop. We loop back to the top of our greater for loop. And now row gets updated to 40, 50, 60. Does that make sense? Then we go into each one of these numbers, 40, 50, and 60. Great. So what we wanted to do was just print out the number itself, right? We want to print out 10, 20, 30, 40, all the way up to 90. Now we don't really need to print this out. We can comment that out. We don't have to print this out either. We can comment that out. And now when we run it, we can see this. We get 10, 20, and 30, right? This first 10, 20, and 30, just like we had before the num. Then we don't have to print out the row anymore, right? Because it's not what it's asking us to do. So instead, we just remove that. And then we keep on going. 40, 50, 60, then 70, 80, and 90. Okay? That make sense? About how to use a nested for loop to go through a 2D list? Right? We've been looking at all these elements, right? We just look at the whole list as a whole, and then we look at the numbers itself. We can update this too to look at indices. Why would we want to look at indices? What if we wanted to do something different? What if instead of printing out 10, 20, 30, 40, 50, 60, 70, 80, 90, what if we wanted to print out 30, 20, 10, 60, 50, 40, 90, 80, 70? Right? Let's do it backwards. How can we do that? Yes?
Maybe you could reverse the data, like right after you create the data.
Maybe you could reverse the data. Sorry, can you repeat that? Reverse the data.
Like on line 4.
Line 4. Okay, I have line 4 here. You're saying to reverse the data here?
Yeah.
Okay. We could mess with data, right? And change it up. But for the purposes of this, I want to keep data the same. And I want to print out whatever data is doing. I don't want to change data. The data should stay by itself. We don't want to mess with it. We just want to read it differently. So let's try and read this. 30, 20, 10, 60, 50, 40, 90, 80, 70, without messing with the data itself.
Okay.
How can we do that? So, maybe one thing we can do, let's just remove all that other stuff, just so we can have it for later. So let's just think step by step. What's the first number we want to print out?
10.
10. We want to print out, sorry?
30.
30, yes. So now the first number we want to print out is 30, right? Where is 30 right now? What position?
0, 2.
0, 2, right? Position 0 because it's in that first list. And it's position 2 because it's the second, or the third number within that first list. 0, 1, 2. Great. We have 0 and 2. Okay, cool. Then the second thing we want to print out is what?
0, 1.
0, 1. Then the next thing we want to print out is what?
0, 0.
Okay. So we have, let me get this stuck. First we get 0, 2, then 0, 1, then 0, 0. What's the next number we want to print out?
1, 2.
1, 2. So 1, 2 isn't the number, it is the position. But the number, yes, it's this number 60. No, yeah, totally fine. Right? What can we see here? Okay? What can we see here? We know that the first couple of numbers, we want to start off at 0, right? Then we move on to number 1. So using a nested for loop, what do we want to start off with? How do we want to read this list of data?
I think you would keep your first line from your other for loop.
Keep your first line from the other for loop. So for row in data, right? Let's just print out, right? Row is equal to the stir of row. Let's just see what happens, right? Aha, yes. We have our rows, just as we had them before, 10, 20, 30, then 40, 50, 60, then 70, 80, 90, which is totally fine, right? This is exactly where we want to be. Because the first number we want to print out isn't this first thing that we're printing out. That's our first number we want to get. How do we get that? How do we get that number? So we're printing out our rows. That's great. Now, how can we start? What position is this number 30 in?
0, 2.
0, 2, right? It's in that second position of that list. Is it the beginning or the end of the list?
Yeah.
It's at the end of the list. And we want to work our way backwards, right? We want to work our way backwards. So how can we do that?
Negative indexing.
Negative indexing, okay. So how do we do that?
For IDX
IDX
in
in
range
range. That sounds good.
from -1 to
-1 is this one. Then this becomes
-2.
-2. Then this becomes,
-3.
all right. -1, -2, -3. So we're starting at -1. We want to get to -3. So if we start at -1, we want to end at -3. Is that going to work?
No,
Why not?
because it's exclusive. So
Exclusive. So we need -4. Cool. Will that work?
I think.
Let's try it out. Now we're going to, just like we've done before, let's just print out what we have so far. IDX is equal to, and we're going to put stir IDX. Let's just see what happens. Right? Let's not commit to anything yet. Ooh. We're not getting anything. What is going on here? So something's not working. Something's not working. We're never actually even hitting this print statement, right? So maybe something's off with this range. Yes?
We have to add a negative step.
A negative step? How do we do that?
Just another comma, then -1.
-1. Remember, for the range function, if you have 3 things in it, you have your starting point, you have your ending point, and then you have your step point. Okay? Your step point. This tells the system, do you want to go forwards or backwards? If you're going backwards, it's -1. So we're going -1, -2, -3, -4. Let's try that out. Is that going to work? Oh! Oh, baby! IDX is now -1, -2, -3. These are the numbers that we're looking for, right? These are the numbers that we're looking for. We could either do it like this, right? 0, 0, 2, 0, 1, 0, 0. Or we can do it this way, right? Of 0, -1, 0, -2, and 0, -3. Because of negative indexing, you can start from the right and go to the left. So now, how can I grab that number? Grab the number that I want. I want to get 30. How do I get 30? We know it's in our row, so we can start off with that, right? Print row. Because it says here row is equal to 10, 20, 30. I want to get to that spot. How do we get to that spot?
0, -1.
0, -1. Something like this. Whoops. Like that.
Yeah.
Okay. Let's try that out. See what happens? Ooh. Int object is not scriptable. Okay. Let's just see what this line is doing. Getting very close. But row, remember row, let's print out this right here. Let's comment that out and print it again. Row is a single list, right? You're giving it 2 positions, 0 and -1. But remember that row isn't the 2D list. It's not this big one, right? It's not this big thing. Row is just one of the lists. So if you give it 2 positions, it's going to freak out. It's going to be like, whoa, I only know about 1 position, right? So instead of 0, -1, we can try to print something else, right? What other position do we want to get? We want to get to that position, this position. What position is this? 2, or negative 1. Either one. It's the same thing. Okay? Let's try that out. Negative 1, like that. Oof. What's going on here? I'm getting 30, 30, 30. I want 30, 20, 10. How do I get that?
Instead of negative 1, put IDX.
IDX instead of negative 1? Right here?
And the printing.
Ah, here. IDX. Okay. Let's run that. Awesome. 30, 20, 10. Let me remove this IDX thing and remove this row thing right here. Awesome. 30, 20, 10, 60, 50, 40, 90, 80, 70. What if I did this though? 70 and 100. Is this code still going to work?
No.
Ooh, why not?
Because for IEX and range, the negative 4, it should be negative 5.
It should be negative 5, right? What if I add another one? Negative 6. How can we change this? So instead of us having to update this number anytime the data is updated, let's just get this automatically updated to whatever data is. How can we do that?
Replace negative 4 with data?
With data?
I'm not too sure.
You're getting close, right? Because what we want to do is make sure that whatever data has, we want to work with whatever data has. Data might have 3 things in that list. Data might have 100 things in that list. We don't know. But we want to work with whatever data is giving us, right? So what we can do is, actually instead of data, because data is like, remember, the big 2D list. It's that big one. We want to work with just whatever's inside. Because right now data is still 3 lists long. There's only 3 lists. But the list within that big list, that has increased. So instead of data, we can do row, right? We can work with the row that we're looking at. Does that make sense so far? Because we're looking at the list itself. The inner list, I should say. Then we could do something like this. Remember the length function? Len? Len will give us what number? What number is this going to be?
4.
4. 1, 2, 3, 4. Can we do this? I don't even know if we can do this. Negative length of row. So length of row is going to be 4. Right? Let me run that. Actually, I don't know if this is going to work or not. Whoa. Okay. So it is working. 40, 30, 20. But we're not getting that 10. We're not getting that 10. Why is that? Here, I'm going to remove this 40 just so we can have the original data that we had before. And when we run that, we get 30, 20, but we don't get the 10. How do we get that last 10?
Subtract 1 to the length of the row.
Subtract 1 to the length of the row. Again, because this is exclusive. Length of row at this point is 3. So if we make it negative 3, what we actually wanted here was negative 4. So we just have to do minus 1. Okay. Run that. Ta-da! 30, 20, 10, 60, 50, 40, 90, 80, 70. Fantastic. Great job. Okay? And that's with negative indexing. Okay? If we wanted to do it this other way, of 0, 2, 0, 1, 0, 0, 1, 2, right? We could have done it very similarly, but instead of doing negative indexing, we could have kept the positive index, right? And instead of going like that, we could have done this. Range of, we want to start off at 2. So we get like the length, we get the length of the row, minus 1. Then, we want to go all the way down to 0, right? Or negative 1. 0 or negative 1?
Negative 1.
-1 because it's exclusive. Whoa, -0. And we can keep this negative step because we want to step our way backwards. Run that. We get the same thing, 30, 20, 10, 60, 50, 40. And that's how you'll get this. 0, 2, 0, 1, 0, 0. The one that we had in right now is 0, -2, 0, 0, -1, 0, -2, 0, -3. Either one would work. Okay? Does that make sense? On how to print out these things out? How to use the range function to look at positions instead? So now, we didn't edit data at all. Data is still the same. But now we're just reading it differently. Okay? How to read this data is a big thing with 2D lists. Okay? Any questions on this? Since we had 30, 20, 10, 60, 50, 40, one last thing. How can we read it diagonally? Just 10, 50, and 90, and that's it. Nothing else. How can we get that?
I would assume that's the third, for IDX and range, instead of being -1,
Mm-hmm.
would it be,
This is a tougher one. Yeah, it's tough. Let's just write down exactly what we want to print out, right? So what are the three numbers we want to print out?
10, 50, and
10, 50, and 8 and 90, 10, 50, and 90. What positions are they at?
0, 0.
We got 0, 0. Then the next thing?
1,
1, 1. Then the next thing?
2, 3. 2, 2.
2, 2. A pattern is emerging. What is that pattern?
They're both adding ones to each.
They're both adding ones to each one, so we get the same number on each side. Then we add one on both, same number on each side. Then add one to both, same number on each side. Right? So what we can do is, let's just comment that out. What we can do is, I'll go through this one more quickly so we can get to the material for today. But what we could do is for IDX, right, index, in the range of the length of data, right? So what numbers am I going to get with IDX when I do this?
0, 1, 2.
0, 1, and 2, right? Because data is a length of 3. So you get 0, 1, and 2. What you can print out is data at position IDX, 0, and position IDX. Because we just want the same number on each side. We're incrementing by 1 every time. So we don't really have to look for another number. If we run that, hey, 10, 50, 90. Does that make sense? How to do that diagonal one? Okay. As a nice little exercise, I'll leave you all as a nice bonus homework for you. Not graded, obviously. Try to reverse it. Okay? Try to reverse it. Instead of 10, 50, 90, maybe try to print out 30, 50, 70. Okay? But we won't go over that right now. We have to move on. Okay? Any questions once you do this? And that's the for loops and how to go through that. Yes, no, yes, no? No? All right. Oh, we just did this. What if I only want to print things along the diagonal? 10, 50, 90. Okay. All right. So for today, new material. New material. We're going to go through images, what they are, what they look like. We're going to go through some tuples. Tuples are, again, a data type, just like lists, strings, and ints and floats. We're going to show images as a 2D list of tuples. We'll get into that right now. And then we're going to actually work with actual real images, okay, actual pictures, and modify them. So, very first thing we want to talk about today is basics of images. What is an image? Okay? What is an image? When we start looking at a computer screen, does everyone or does anybody here know? Does anyone know how to use an eraser? Not me, obviously. When we're looking at a a computer screen, how is the computer screen showing us that picture?
Pixels.
Pixels. Never heard that word in my life. But yes, pixels. We're getting started. A pixel, what is a pixel? Can you tell me what a pixel is?
Isn't like those small circles in the...
Small little circles, right? Small little squares. If you were to come up right here, you can see little squares, right? Very, very small. Those squares have a total of just one color, okay? The square that's right here, what color is it?
White.
White. What about this one?
White.
What about that one? Black. What about that one? Blue. Okay? But it's one little small square. That's it. But a large collection of these small squares create pictures. Okay? They create pictures. Something like this. Maybe one little small square with one single color won't give us much. But now, with this bigger collection of squares, what is this picture? It's a heart, right? We can create images using these things we call pixels, right? Pixels are, again, just a small square with one color in it. Nothing else. That's it. What is this?
Yin and yang.
Yin and yang, okay? Yin and yang sign. And we can do that again with just these little squares. Just these little squares. This is just black and white. This is white and red. Okay? Pixels are, again, one small square. How many pixels wide is this? Have a look at that answer. How many pixels wide is that? 7. 1, 2, 3, 4, 5, 6, 7. How many pixels tall is this? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Great. I'm not going to ask you to count this up. But basically, pixels are just that little square. Pixels together in a collection create an image. And we can look at an image a certain amount of pixels wide and a certain amount of pixels tall. Okay? Maybe if you were to open up like an image on your computer and you look for the size of it, it'll give you like one number, X, another number. And that's just how many pixels tall is it and how many pixels wide is it. So this is 9 by 7. Okay? 9 by 7. 9 pixels tall, 7 pixels wide. Or maybe it's the other way around. I don't remember. But basically, it'll give you two numbers. And one is how tall it is, and one is how wide it is. Okay? So this is just like images again as pixels. UCSD actually has like a little pixel art competition. You can see a whole bunch of pixel art that students have made before. And again, these are just pixels, right? You can actually see some of the squares. Let's look at, okay, this is our 16 by 16 submissions. So it's 16 pixels wide and 16 pixels tall. And actually, if you really go in there, you can really count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay? They're actually just pixels, right? And we're editing the pixels. And this is just some artwork that people have done. Very talented people. Nice little rock bear. I think this is actually one of the UCSD CSE like sweaters. Hey, look at that. Look at Audrey in the back, our wonderful TA. That pixel art is this. The one with the surfboard and the glasses. Awesome. Thank you, Audrey. That was on purpose, by the way. Totally on purpose. Yeah. That's so cool. Yeah. So, pixels. We can use pixels to our advantage, right, to create images. We can make a pumpkin with a face on it, a jack-o'-lantern. We can print out Santa Claus, right? How can we make this, right? The way that this works is each one of these pixels, right, is one color, How does that pixel know it's going to be the color white? How does it know it's going to be the color red? How does it know it's going to be the color black? Anyone have any guesses on how to do that?
Maybe giving it the color by position.
By what, sorry?
Position.
By position, right? So you're saying like at position 0, 0, I want it to be white. Like that, right? How, okay, okay, that's a great way of doing it. Let's do that right now. Picture. I'm going to say at position 0, 0. I want it to be white. Is Python going to know what white is?
No.
No, not yet. We have to tell it what white is. Okay? And the way that we do that is with something called RGB values. Has anybody ever heard of RGB values in the past before? It's okay if not. I didn't know about it until I started learning about this stuff. Yes, anyone know? Yes. Someone that knows about RGB values, can you tell me what an RGB value is? Yes?
It's like 3 integers or like floods, red, green, blue.
Right, so 3 numbers, red, green, and blue. Red, green, blue. RGB values. This is red, this is green, and this is blue. Okay. When we mix colors together, we can create a whole sort of an array of colors. Let's actually look at that right now. Let's just look at what that looks like. Okay. RGB values. Okay. Color codes chart. So this is a color code chart. Let's say I want it to be red, right? At this position of red, if I want that red color specifically, I would need 230 values of R, which is like red. I need 40 values of green, and I need 40 values of blue. Okay? So to get this specific red color, that one, my RGB values would be, can someone read out those numbers for me?
230.
230,
40.
40,
40.
and 40. Awesome. So to get that specific red, I would need those values. That's my RGB value, right? We get 230 units of red, 40 units of green, 40 units of blue, mix it all together, and we get that red color. What if I wanted that red color? Looks similar, but it's not the same. Okay? You would want 246 units of red, 34 units of green, and 34 units of blue. Okay? So that's what RGB is. The computer will know what color to give you based off these 3 numbers, R, G, and B. Right? All this other stuff we don't have to worry about. This goes into like color theory and stuff like that. We don't have to worry about that right now. Just look at these 3 numbers, R, G, and B. Okay? So, what if we max out these numbers? When we get all the colors of R, G, and B, and put as much as red and as much green and as much blue as we can, what we get is this color. What color is that?
White.
White. Okay? RGB values do not go past 255. Okay? So that's the max it can be. 255. So when you have 255, 255, 255, that is white. What about the absence of color? What if we made it all zeros? What might we get? What's the opposite of white? Black. Here, we get black. 0, 0, and 0. So when we look at this, right? And we say the picture at 0, 0, what RGB values would we want to give it if we want it to be white? Or we want to max it out? 255. Like that?
40, 40.
For-
You want all of them to be 255?
All of them to be 255. Okay. 255, 255. Great. So how are we going to store that information? We could use a list, right? We've used lists before. But we have a new data type. And it's called a tuple. Okay? It's called a tuple. All right. Okay. So again, just really quick, with these images, how many pixels are there in this image? And what are the unique RGB values of these pixels? Right? Can someone tell me how many pixels there are in this image? Actually, this is going to take a lot of counting. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pixels tall. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pixels wide. So there's going to be a total of how many pixels? 16 times 16. If we have math whizzes out there, what's 16 times 16? We can use our handy.
256.
Hey, 256.
Maybe.
Maybe? Oh, dang, it is. Nice. Cool. Thank you, Tyler. 256. So there's a total of 256 pixels in this image, right? And what RGB values are there? How many unique RGB values are there?
White and black.
White and black? What values are those for RGB? Because we could say white and we could say black. But what if this is like slightly off-white? Right? It's not exactly, like two whites are not the same. So let's just assume this is pure white and this is pure black. What numbers are they? What's white's RGB value?
255 for all of them.
255 for all of them. And what's black's RGB values? 0 for all of them. Awesome. Okay. So now, where we're saying, I want to make that pixel, the picture at position 0, 0, I want it to be white. We're going to introduce this new data type. It's called tuple. Okay, tuple. Tuples are very similar to lists. This is the way I like to think about them. But tuples are very similar to lists, except for one very key thing. Tuples are not mutable. Okay, they are immutable. You cannot change what that tuple is. Right? So when we're working with lists, right, let's just look at right here. Let's just remove all that stuff. When we're working with lists, right, you have LST is equal to 1, 2, and 3. Before, what we can do with lists is this, right? List at position 2. What is list at position 2 right now? 3. Let's just change that to 10. What's going to get printed out when I print this list now?
2, 3, and 10.
2, 3, and 10?
Oh no, 1, 2, and 10.
1, 2, and 10. Right? Because we can update it. That's a mutable object list. We can grab it. Remember when we showed it before? We'd grab something, mutate it, actually change it up. It's going to be the same object, that same thing, but we're going to change it into something else. Right? When we're working with tuples, tuples are very much like lists, except they're immutable. And the way that you show that is with, oh, that's neat. Did it automatically. Instead of square brackets, we use parentheses. Okay? Parentheses 1, 2, and 3. When I do this, I'm going to get an error. Okay? Because tuples are immutable. You cannot change them. What else is an immutable object that we've seen before?
Strings.
Strings, right? You could see a string. You could see like what's the first character of a string, the second, third, fourth, fifth character of a string. You can actually look at it. But when you try to change it, you can't do that. Okay? You cannot do that. So, tup, tup. Now we're looking at tuples. Tup. So when we print this out now, tuples 1, 2, 3. But you could also still look at the positions. The positions work the same as in lists. So how can I print out the number 3? What position is number 3 at?
2.
2. Run that. You got 3. Okay? So you can still look at it, right? You can still see these things. You can still see what's happening inside the tuple. But if we wanted to change the tuple to be instead of 1, 2, 3 to 1, 2, 10, how can we do that? Can we? Are we allowed to? One thing we can do, if we wanted to change our tuple to be from 1, 2, 3 to 1, 2, 10, is instead of grabbing it, mutating it, right, this object, we're going to have to get a different object, a different tuple. We can still use the same reference, right, of TUP, this variable name, tup. But now tup is going to have to be equal to 1, 2, and 10. Okay? That's how we would have to update it. So now, let me just print, so let me print up tup here, and print out tup over here. So tuple was first 1, 2, 3, then we changed it to be 1, 2, 10. Okay? But we had to change it to a completely different tuple object, right? Because we cannot mutate it. Does that make sense so far about tuples and immutability? Cannot change the tuple itself? Could we have done this? So, 1. Yeah. Would this work? Yes? Why yes?
Because you're only reading.
Because you're only reading it, right? You're creating a new tuple, right? With this. But before you set this tup equal to something else, is going to have to find out what is this something else that I'm being equal to. Here, we're making it equal to tup at position 0, tup at position 1, and 10. So we can read the tuple itself, right? So when we run this, it'll still work. We can read it, but when we're creating this new tuple object, it uses the original tuple object, this original 1 and this original 2, right? It just reads it. And now we're doing something else here with a 10, closing off with parentheses, and this is a new tuple object. Okay? Does that make sense about tuples? Right? All this to show, right? All this about tuples to show that tuples are what we use when we're working with RGB values. I have a little spoiler right here with these parentheses. So instead of those list square brackets, what we want to do is this. Tuple. Okay? Tuple. Any questions on tuples so far? Yes, no, yes, no? Okay. So this is just a small code example of what we were doing right now, right, with tup. But let's assume we have red. Red is 25500, aka as much red as possible, then no green and no blue. Then green is no red, as much green as possible, then no blue. Then lastly blue, no red, no green, and as much blue as possible. 255. Okay? So green is that tuple. Green at position 1 is 255. Green at position 3, you get an error because, again, just like lists, if you go out of range, Python's going to get mad at you and say, whoa, stop that. Right? I can't read this. There's nothing there. Right? Let me see. Oh, we already went through all this. Okay? So let's assume that we put black at 000, or sorry, 001. Whoops. So if we want the color black, and it's supposed to be 000, but we accidentally mistyped and put 1. If we wanted to update this, how can we update this? Can we do this?
No.
No. Okay, we cannot do that. How can I update black to be 000?
Because put parentheses 000.
Yep. Great. That's how you would have to update it. Okay? You cannot mutate a tuple. What's going to happen when we run this code right here? here on the left. What's going to get printed out? Any guesses?
I think B.
You think B? Let's work it through. Why B?
Like on the first 4 lines, you just create like new integers values for each value inside the tuple.
R, G, and B,
Yeah,
right? So what is R at this point?
255,
G
100,
and B?
0.
Okay, awesome. Then what happens?
And then on the next line, you set the G value to 165.
Great.
And it doesn't change the tuple, it just changes G.
It just changes G. Tuple stays the same. Orange is still 255, 100, and 0 at that point. Great.
And
Then,
then the next line, it prints out 255, 165, and 0.
oh, that's at this line right here, right?
Yeah.
What happens here?
You set orange to like a new tuple.
You set orange into a new tuple, which is R, G, and B. What is R right now? Here?
255.
G, what is G now?
165.
165, because it got updated right here. And what's B?
0.
0. So when orange gets updated, it's 255, 165, and 0. You can try that. Awesome. Great. Any questions on this tuple and how we can access it, use it, harness it, and change it whenever we want? Any questions on that? Yes, no, yes, no? Anyone a little confused about tuples and how they work? No? Yeah, question?
Oh yeah, but I was just wondering because like you know how in a list is mutable, but
Yeah.
the tuple is not mutable.
Yep.
So like, what would be like the benefits of that not being mutable like in the program?
What are the benefits of it not being mutable in the program? Great question, right? One of the answers to that, which gets into like really like higher level theoretical stuff, is like memory and space and how computers read these data types, right? How much like space is allocated for these things. But in a more like practical sense, when we are programming, typically if you have a tuple here, you don't want that tuple to change. You want to keep that tuple the same, right? We want to save it, that memory as much as possible, right? That's maybe one of the reasons why we would want to use a tuple instead, right? You don't want to be adding new things to it. You don't want to append things to this thing, right, to the tuple. You don't want to easily change stuff, right? Or kind of like what we had before, right? When we had a function. So what happens when you pass in a list into a function, right? And you change the list within the function. What's going to happen to it?
Once it steps outside, it won't have that frame. The frame won't.
Right, so when we're working with frames, right? When we're working with frames. So when you step into the function frame with a list, when you change that list inside of this function frame, it still gets updated on the global frame because of the way that like the pointing thing works, right? Because it's mutable, you could change it. So if you mess with a function inside, if you mess with a list inside of a function, that list is still messed up when you come out here. Not with a tuple. If you pass in a tuple, right, you mess up with that tuple inside the function, when you come back here, that tuple did not change because it's immutable, right? You're passing in the tuple over here to this function, but when you leave that function, the tuple that you passed in stayed the same. Okay? That makes sense? So tuples are basically more rigid, right? Things you don't want to change as much. That could be one of the reasons why. Okay? Thank you for the question, though. Any other questions on tuples? Yes, nice, no? All right. So, images are basically 2D lists, and inside of those 2D lists, we have tuples. So this image right here, how many pixels is this? 4 pixels. How many pixels wide? 2. How many pixels tall? 2. Pixel at 0, 0. What color is that? Red. How can we make red? With a tuple. Have as much red as possible, 255. No green and no blue. How about this next pixel? What color is that? White. What values can we put to make white? 255, 255. Maxed out. Next pixel. What color is this?
Green.
Green. How do we make green?
0, 2, 55, 0.
Yeah, 0, 2, 55, 0. And then lastly, what color is that?
Black.
Black. How do we make the pixel black?
0,
0,
0.
0, 0. No cheating. 0, 0, 0. Okay? Because the absence of any red values, any B values, any G values. It's all 0. Okay? And the way we do that is as follows. So you know how we had our data before, right? And we had our list of lists. And we had 10, 20, and 30. We had 40, 50, and 60. Right? This is a 2D list. Well, now what we can do is instead of having numbers inside of that inner list, we can have tuples, right? So the first tuple that we had was red. How do we make red again?
255, 0, 0.
0, 0. Then we can have, what was the next color? White, I think? Yeah, white. 255, 255, 255. Then you can have green, 0, 255, and 0. And then lastly, black, 0, 0, 0. Okay. This is a 2D list of tuples, right? What if I wanted to print out this green value? How do I access that green value?
Data 2.
Data 2? Like this?
Yeah.
Let's try to print that out, see what happens. Ooh, drat. List is index out of range. So how many things does data have right now? How many lists does data have?
2.
There's a total of 2 lists, right, inside of data. Data is one big list, right?
Oh.
Then, if you do data at position 2, data is going to say, okay, here's my first thing, 0. Here's my next thing, 1. Here's my next thing, 2. It doesn't exist. It's out of range, does not exist.
I see they're confused with the...
Yeah. This is when it gets a little tricky, right? This is when it gets a little tricky. I think this is going to be like one of the last real big concepts we learn in this class. Like a big one. A 2D list of tuples, right? So how do we get this right here? 0, 255, and 0. How do we get that?
Data 1.
Data 1,
And then the 0.
0. Okay? Run that. 0, 255, and 0. Great. And the reason why that works is because when we print data, so when we print data first, it's just list of lists, right? A 2D list with tuples in it. Then we print out data at position 1, because that is going to give us the list at position 1. So 0, 255, 0 as one tuple, and 0, 0, 0. Then we get the position at 0. The 0, 255, 0 is our last tuple. Does that make sense? About how to access our 2D list again? Yeah? Accessing our 2D list? So we have something like this. We had it just like before. We have our red, our white, our green, and our black. We have red, white, green, and black. Okay? Oh, actually, that's exactly what we did. So when you have your image at position 0, it's like your full big honker 2D list, right? That's your image, and then you get the position 0, so you get the first row, right? The very first thing. And then if you look for a specific pixel, you get the second position of it, right? Oh, and you're getting even into the third position. How do we get the green value of this data? So this one right here, this is our tuple for a green pixel. If we want to see how much green we have in it, how do we print that out? What?
Like data is 101 and 1.
Data 101. Data at position 1, at position 0, at position 1. Because again, it's RGB values. We got our 255. Great. Awesome. So, what am I doing on time? I got, okay, I got like 10, 15 minutes. I got 15 minutes left. Awesome. Great. So, oh damn, we just did this. How can we print the RGB tuple for green? Okay. Does someone answer that? How do we print out the green?
IMG 10.
IMG 10. So IMG is our 2D list, our list of lists. Then IMG at 1 is going to give us this list right here, green and black. Then IMG 1 at position 0 is going to give us that green. Okay. And it ends up being 0, 2, 55, 0. Great. Now, we're going to start working with actual, factual, real images now. Okay? Actual, real stuff. Things you see on Instagram. Things you see on the interweb. The things you're seeing right now. This is a picture, right? A slide. And a slide is just a picture. Right? We can actually grab these images and work with them. Okay? So, as we've seen before here, right? With this image is just a 2 by 2 pixels, right? A total of 4 pixels. 2 by 2. A lot of times, you're working with tons of pixels. Okay? Tons of pixels. Let's look at this over here. We'll work with some images. I have a couple of images here lined up. Here's a cat. Right? Here's a cat. This cat, let's see, open an image in a new tab. Can I do that? This cat is, I don't know if you can see it, that's really small. I can't zoom in. But this cat image is 800 by 600. Okay, 800 pixels by 600 pixels. This is a big image, right? We're working with 2 by 2. Now we're working with 800 by 600. Okay? So, this image of pixels, 2 by 2, imagine that, but 800 by 600. Each individual pixel has its own individual color, right? And we can actually see those things. And we provided something called, let's see, where is it? We provided something called the CSE 8A image library, okay? And the way we do that we can use that is using from CSE 8A image import star. Star just means everything. Import everything that exists within this file, CSE 8A image. What is import again? What does import do?
It brings all of like code or something that was from another person wrote.
Yeah. And you bring it in, and you say, I want to use whatever you wrote. Okay. And we did just that. We have a bunch of stuff here. Please do not edit this file. 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 Okay? We should not edit this file because if you start editing this, it's going to mess up all your nice work that you're doing over here. Okay? Because CSE 8A image, right, it only works if we don't edit it, right? We know that these things work right now, so we shouldn't be changing this stuff. CSE 8A image file, should we edit it? No. Okay? This stuff is pre-written, and we don't want to mess with it. Like, what is import numpy as np? What is from PIL import image? We don't got to know any of that stuff. Okay? We don't have to know, because we're just going to import it. And we're going to use whatever someone else wrote into our file. Right? Only things we got to know about CSE 8A image is the things that it can do. Okay? What can it do? Well, we have a neat little chart here that shows us exactly what it's going to do. Okay? We have a function called load image. Load image. What will load image do? It's a function that takes in a string containing the file name or file path where the image is, and the function returns the 2D list representation of the image. Okay? What does all of that mean? We need to know a file name, right? So if you go up here on your EdStem, it's going to be a little button that says files, right? And within files, there's a little folder called images. And here are all the images that we're going to be using right now. There's a cat. There's Grace Hopper, right? Famed computer scientist in the United States. We have a star, very small star. And we have Cholo. This is a Cholo squinkle. One of my favorite dog types out there. Hairless. Great for not having hair all over your body. Right? Cholos. Very beautiful painting. This is a painting by Gustavo Remada. Great artist. I have a couple of his things at home. But anyways, let's see. I want to grab this Cholo image. This image, this JPEG file. I want to read it in. I want to see what it has. I want to see the 2D list of all the tuples. How do I do that? Well, I can have my image be equal to load image. Okay, load image. Load image exists within CSE 8A image. Are we going to edit that file of CSE 8A image? No, we will not edit it. But we will use the things that are inside it. Okay? One of the things that it has is this thing called load image. Okay? So in load image, all it's asking for us to do is give it a string with a file name. Right? It needs to find that file. Right? So if I want to print out cholo.jpg, right? That's my file name. What I have to do is put here images / cholo.jpg. Okay? The reason why I have to put images first is because this file of cholo.jpg exists within images folder. Okay? So what your system is going to say is we're in this transformation.py file, right? We're in this file, transformation.py, where we're reading stuff. We're here. If I want to grab the image file of Cholo, it says, okay, I'm here. What am I looking at? I see that there is a folder called images. That's where we're getting it, images. All right? Once I get images, you can also use any one of these, right? And I want to use cholo.jpg. So when we do that, we run it. Woo! No errors. Let's print out my image. What's that going to look like? Oh, buddy! Look at all those chickens. Do you know that? Yeah. Okay, in fact, it was so much stuff that there was too much output. SM was like, oh, buddy, there's a lot of stuff. Okay, I'm just going to stop printing because this is just a ton of stuff. Right? This is too much for me to even give you. Right? If we try to scroll up, look at all those numbers. Whoa! Right? There's a bunch of stuff. In fact, there is, let me see. Let me open image in a new tab. This is 704 pixels by 800 pixels. It is a huge image, right? It's a big old thing. So this is a 2D list, right? A 2D list. Actually, let me pull that up again. Image in a new tab. Ta-da. So this image right here is 704 pixels by 800 pixels. So there's 704 pixels like this, and 800 pixels like this. Okay? We actually have a function that we wrote in CSE 8A image. Are we going to edit CSE 8A image? No! Please do not edit it. But we can use it, right? So we have this thing. So instead of printing out the whole image, let me just print out the height of the image. We have this thing called height. Okay? So when you print out the height, it's going to give you how many pixels tall is this? The height is 800 pixels. Okay? We have another thing called width, right, of my image. How wide is this image? It's 704 pixels wide. Okay? So in total, how many tuples do we have in there? We have a grand total of 800 times 704. That is 563,200 tuples. That's a lot of tuples. Okay? That's a whole bunch of stuff. And if I want to see that image, we also have something called, what we do is, we're going to do something called save image. If we save our image, and we put in our 2D list, and we give it a new file name, we just call it solo new.jpg. This save image is found inside of CSE 8A image. Are we going to edit CSE 8A image? No! Do not edit it. But please use what's inside. Save image is just going to let us see that image. Look at that. What a wonderful new picture. Okay? And what we can do is now use the actual images to do some real cool stuff. Okay? So before we do some real cool stuff, what is this going to do? We have an image, which is a 2D list of tuples. And we're going to print out the height of the image, x the width of the image. What's the answer to this? Three and two. It is 3 pixels tall. 1, 2, 3. And it is 2 pixels wide. 1, 2. Okay? 3x2. Okay? So what we want to do now is grab our original image, change the tuples. That's wild, right? We said we didn't want to be changing tuples all that much. But for example, in this image, it's great to have it as a tuple because we won't want to mess with it too much often, right? But now we're going to do something called a filter, right? We're going to go in and we're going to actually change some of these values to make it transform. This is like dimming. This is going to dim the image, right? So when we dim an image, what are these pixels doing? Are they turning more on or are they turning more off? Off. When you're turning more off, what's happening? What are the numbers happening to it? Getting lower, 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 lower. Okay? You're going to get these pixel values and make them lower. Okay? One way we can do that is the following. Yeah, iterating through the image, making the whole image one color, making half the image one color. Ooh, wow, okay. Let's do this one first. So, we have our image. It's a 2D list, right? How can we iterate through a 2D list? How have we done that before?
Nested loops.
Nested loops. So for, I'm going to call it row in my image. I'm going to go do range of length of my image. Okay. Then I'm going to do for call, like for a column. I'm going to call it column. In the range of the length of my image at position row. Right? So row is going to be all of the ones in the top, and the column is going to be all the ones on the right. Actually, instead of using that, we can use that really nifty function that we got the height of the image, my image. And instead of the height, instead of all this, we can also do the width of the image, my image. Right? Whoops. Is that going to, oh, sorry. Height of the image is going to give me a number, right? And we're going to try to iterate through a range of numbers. We have to do this. Oh, it's time. It's about to be time. Oh, doggy. Sorry about that, y'all. Well, let me just make this real fast. Okay. So if we have the row and the column, what we can do is print out my image, at position row, at position column, right? Column. Let me print all that out. If we were to print that out, it's going to print out every single individual tuple, right? A bunch of stuff, right? And right now it's all white because of all this white border, okay? And what I can do is I can change the colors to be a different color. So what I can do is my image, which is a 2D list, lists are mutable. I'm going to say the row and column, right? I want to make this all one color instead. I'm going to make it all black. What I can do is I can give it a new tuple, right? It used to have a different tuple, right? Where we'd print stuff out. But now I can go to that position in the 2D list and change the tuple itself and make it all black. So when we finish, we can save the image into my image. And then we're going to name this Sholo black.jpg, right? And when we run that, our image is now all black, okay? It used to have all these nice, vibrant, different colors, but now we made it just all black, okay? How did we do that? We went